Okay, so we're doing 11.4. Today we're talking about area of regular polygons and composite figures. We're going to jump straight into finding the area of a regular polygon. Before we could do that, we have to identify what an apothem is. An apothem is a segment drawn from the center, ouch, there, my finger, of a regular polygon. So a segment drawn from the center of a regular polygon to a side a segment drawn from the center of a regular polygon, perpendicular to a side. Of the polygon. A segment drawn from the center of a regular polygon perpendicular to a side of the polygon. So here, let's say this is the center of the polygon. We have our radius or radii going from here to here, here to here. So if we're going from the center to a side, because that's a side of the pentagon, right? Then that would be called our apothem. Everybody got it? So it's kind of like the height of the triangle. So we have a triangle with 2 radiuses, or radii, and so the apothem is that height. And so that's what an apothem is. You'll need to know it to find the area. Also, if we're trying to find the central angle, we did this back in the earlier chapters. If you remember, we talked about how it's 360 divided by n, but you probably didn't really know what a central angle was. Well, now you know. And so if we have to find a central angle, it's 360 divided by n. You need to know that because when we find area of a polygon, these two are very key important terms. So here we're just going to practice identifying parts. Square FGHJ is inscribed inside a circle K. Identify the center, a radius, an apothem, and a central angle of the polygon. Then find the measure of each central angle. So of course you know the center, that's the easiest. Center is K. K is in the middle, everybody see that? We can figure out the radius. There are 2 radiuses, or radii. We have KH and KJ. KG, sorry. Then we have our apothem, which is going from the center to a side of the square, and that's KL. And I'm writing backwards, so sorry. And then what else did it want? Oh, it wanted to know the central angle. So the central angle is the angle, of course, coming from the center. And so the central angle here would be angle GKH. So those are the different parts. Got it? So now we're going to jump into the area of a regular polygon. And so an area of a regular polygon, if you look on your formula chart, tells you that area is the apothem times big P. What does big P stand for? Hopefully you said perimeter of the base, all divided by 2. Got it? So you would have to, of course, find out what your apothem is from the center to a side is our apothem. And then we would multiply that times the perimeter of the base and take half of that. So here's how we do it, the process. So we have a regular hexagon here. If you look at the hexagon, we see it's giving us one of the sides is 3. The actual apothem is actually unknown. So we're going to have to go through and figure that out. This is the first step. First, we would have to find out what is that actual angle, that central angle. And so we use that step 1, the 360 divided by n, right? Remember, n stands for the number of sides. It's a hexagon, so of course we have how many sides? 6. So 360 divided by 6 tells us that central angle is going to be 60 degrees, right? So if this, and it's easiest to pull the triangle out. So if we know the whole angle is 60, then what did that tell us about half of it? Hopefully you said it. It's a 30, 60, 90, because we could split both of those up into 30. Everybody got it? We know that it's 3, so we know that each one of the sides can be 1.5. And so then from here, we can use special right triangles to figure out what the apothem is. Our apothem is that side part in the middle. So it's across from the 60-degree angle. So if the 30-degree angle is 1.5, then the 60-degree angle, hopefully you said that the apothem is equal to 1.5 square root of 3. Everybody got that? And so that is our apothem. So now we can find the area. So area equals the apothem, which is 1.5 square root of 3, times big P, perimeter of the base. So we know that it's a hexagon. So we do 3 times 6. So we know our perimeter of the base is going to be 18 all over 2. And so then what is our area going to be? Hopefully you put it all in your calculator. It's going to be approximately 23.4. Everybody got it? So how did we do that? We had to find the apothem. After we found the central angle was 60, across from the 60, we know that's x squared root of 3. Our x was across